Okay, welcome back. We are going to continue. Hold on, let me get this fixed again. Okay, we're going to continue with some applications of laws of sines, some more, and also we're going to take a look at, we're going to start with the area formula. So it says the area equals 1/2 BC sine of A, 1/2 AB sine of C, which is also equal to 1/2 AC sine of B. It's like, well, which one is it? What does all of that mean? Basically, the area formula, if you're given two sides and the included angle. So let's take a look at this picture right here. We have a triangular lot. It contains two sides that measure 24 yards and 18 yards. And those two sides form an angle of 80 degrees. Okay, so anytime you have two sides and the included angle, the angle in between, the area formula is 1/2 the product of the two sides times the sine of the included angle. So those equations are all the same. If you know BC, the angle in between is A. If you know side A and B, the angle in between is angle C. So that's all that's saying. Okay, so if you type that into your calculator, you'll end up getting 212.7, and this is area, so it's square yards. Okay, very simple. All right, so let's get to some other story problems. We've done bearings in the past. If you don't remember bearings, we'll review it with you. So let's take a look. It says, on a small lake, a person swims from point A. So anytime you say from point A, what I would do is I would draw a picture, obviously. And I'm just going to put it right in the middle because I'm not sure which way we're going to go here. So here's point A. When we're doing bearings, bearings are a way of navigation measurements. So what I recommend is always putting a imaginary north-south line through any point that you're traveling from. Okay, so from point A to point B on a bearing of north 28 degrees east. So that is saying take your north and rotate towards the east. Which way is east? Okay, so somewhere in this direction. So from the north to the east, that will be 28 degrees. So it's saying that point B is somewhere in this direction. I don't know where. I'm just going to guess that it's right here. Okay? Actually, I'm going to move this down a little bit because I'm going to run out of room. So let's try again. I'm going to say point A is down here. And I'm going to go in this direction, north 28 degrees to the east. Northeast. Again, point B is somewhere along this bearing. Now, the person then swims, that should be probably a then, swims to a point C at a bearing of north 58 degrees west. So where are you swimming from? You're swimming from A. So again, I like to put in my north-south lines because that helps me with my bearings, and it also helps me see that north and south lines are parallel lines, as we will need to use. So north 58 degrees to the west. So from the north, I'm going to rotate this to the west 58 degrees. And again, it's just a guesstimation. This is 58 degrees. Okay. Now it says to point C. And point C is 800 meters due north of A. Due north means directly. So due north, directly to the north. Due west, directly to the east. So it's telling you that they're on the same north-south line. Okay? So that means that point C is on this bearing and north of A, so point C has to be there. Okay, so that's everything we know. It says, how many total meters does the person swim? Okay, so we swam here. That is side C. And then we got here and turn in this direction. That is side A. So we need to find side A and we need to find side C. Let's go ahead and start with side A. Okay, so again, starting with your unknown. A is to the sine across from angle A, which is 28 degrees. Whoops. 28 degrees. Now we have to find a given, a fact. Well, it did tell us that A and C were 800 meters apart. So that's going to be our given. 800 is to angle B. Well, how big is this angle B here? I guess that's the question. Can we figure out how big angle B is? Well, we're going to have to use our geometry skills here to find some things. 28 degrees is inside the triangle here. 58 degrees is outside of the triangle. However, from geometry, remember alternate interior angles. So you have two parallel lines cut by a transversal. So parallel line to transversal, transversal to parallel lines. Those are alternate interior. So if this is 58, then this angle must be 58. So if we know that this is 58 and this is 28, can you figure out angle B? Yes, we can. And that's 180 minus 28 minus 58. Angle B comes out to be 94 degrees. That's this angle right here. So 800 is to the sine of 94 degrees. So if you draw a very small picture and you don't dot in your north-south lines, it makes things very, very confusing, and you have to remember your geometry. Okay, so we can go ahead and type that into our calculator, multiply both sides by the sine of 28 degrees, and you will find side A. And 800 divided by sine of 94 times the sine of 28 will give you 376.49. In this case, we're talking meters again. Okay, so we found side A. Now we need to find side C. Again, this is not a right triangle. There's no right angles that we've proven. You can't assume anything. So now we're going to find angle C. Side C. So I'm going to start with my unknown. Side C is to the angle across, which we already calculated is 50 degrees. Sorry, again, that's sine of 58 degrees. And we can use the same given information that we used in the previous one. So 800 divided by the sine of 94 degrees. Okay, well, in your calculator, you should already have 800 divided by the sine of 94, so you can scroll up there and find where it says multiplied by the sine of 28 and change the 28 to a 58. Again, use your calculator wisely, save yourself some time, and 800 divided by the sine of 94 times the sine of 58 degrees is going to give you 680.095. So the meters. So the total meters that the person swam was 36.49 plus 68.095 for a total of 1,056.6 meters. That's your final answer. Okay. All right, let's try another bearing problem. If you want to pause the video and see if you can draw the picture, so you can practice, that would be fine, and then you can come back. Okay, So it says a plane flies 500 kilometers with a bearing of 316 degrees. Right? Well, it doesn't say what direction. So it's understood, if it doesn't say what direction, it's understood that it is north 316 degrees to the east. That's the standard bearing, north to east, like a compass. Okay, so let's go ahead and pick a point that we want to start at. I'm going to go over here because I know I can kind of estimate. Again, if this is where I'm starting, as I recommended, always draw in an imaginary north-south line to help you with your, to be able to see everything. Dotting that in, this is your starting point right here. Now, 316 degrees from the north, again, you're taking this north and you're rotating it. So if I rotate it all the way down here, that's 180. If I rotate it up to this point right here, that's 270, and all the way around is 360. Well, I want 316. So again, I'm just going to estimate that somewhere in this direction. All of that is 316 degrees. Okay? So if that's 316 degrees, what's left? Then I know this is 44 degrees. But I might use that, I might not. I'm going to put that in there. Okay? So the plane flies 500 kilometers. So we are flying on this bearing. We're going to go 500 kilometers. And after 500 kilometers, from Naples to Elgin. So this is Naples. Elgin is somewhere here. I don't exactly know where. I just know it's on this bearing somewhere 500 kilometers away. The plane then flies 720 kilometers from Elgin to Canton. And Canton is due west. There's that word again, due west of Naples. So that's nice because it tells us that it is directly to the west somewhere. We don't know how far. I think that's what they're going to probably maybe ask us to find. Maybe not. I don't know. So if we're here again, if this is where we're flying from, okay, and it says back to here, what was the bearing? Oh, it didn't tell us. It just says that from this direction, you go 720 miles to Canton. So if Canton is here, then obviously, probably further down here, because this is 500. This, what they're telling us, is Canton, due west of Naples. And you flew from Elgin to Canton 720 kilometers. So do we have all of our numbers in there now? The 316 is up to here. So that angle is 44. What's this angle right here? Let's see if, I don't know if we're going to need it, but it might not hurt. If up to here is 270, what's 316 minus 270? That's 46. So does it make sense that these two angles right here total 90 degrees? Okay. What else do we know? Well, we know that these are north-south lines, right? So, and this is east and west because it says due east. So you can only assume that when they tell us. So from here to here is due east. This is a north-south line. So I know these are 90 degrees. I know that's true. I know if this is 44, this one right here is 44 because those are alternate interior. Again, parallel line to transversal, transversal to parallel line. Those are called alternate interior. I also know that this is 44 because, see this little right triangle in here? 90, and these have to total 90. So I also know that. All right. So what do they want us to find? Find the bearing of the flight from Elgin to Canton. Okay, well, where is that? What are they asking us to find? Okay, so find the bearing. So from the north of Elgin, if I've taken again, the bearing is clockwise from the north. How much do I rotate to get to here? Well, up to this point right here is 180 degrees, so I just need to find this theta right here. If I just find this theta right here, I can add it to 180 and I've got my bearing. So, how can I find this angle? Well, I know this is 90. It'd be really nice if I could find this guy right here. Angle C. So I can find, let's see. So let's go ahead and go with our law of sines. My unknown is angle C. So that's what I'm going to start with. Do I know side C? Well, I do. 500 kilometers. Do I know another angle inside the triangle? Actually, I do. Right here. I know this angle, the sine of 46 degrees. And look at here, right across, the side that goes with it is also given. So I have everything I need to find angle C. So go ahead and multiply both sides by 500 and take the arc sine of your answer and you will get angle C. Arc sine, angle C, you should get 29.969 degrees. That's angle C, but that's not the question. The question is find the bearing of the flight. So we're still trying to find this angle right here. Okay. So these two, in this little right triangle here, these two have to total 90. So if I take my 90 and I subtract my 29.969, this little theta right here, I called angle theta, is 60.031 degrees. So from here to here is 63 degrees. Now, so if it's for a bearing, you can say a bearing lots of different ways. That's the standard bearing, when it says a bearing of. That's assumed from the north, you're rotating to the east. So I could say that I'm going to travel on a bearing of, and that's 180 plus the 60 degrees, which is a total of 240 0.0 degrees. Okay, that's the same thing as saying north 240 degrees to the east. Or you could start from the south if you tell me you're starting from the south. So from the south of Elgin, if I'm starting from the south, how much do I rotate this direction? If I'm starting from the south, I say south, rotating 60 degrees. And what direction is this? From the south, what direction is that? Actually, that's to the west. So any of those answers, you could also say northwest, but that would just require more calculations. So any of those is the correct answer. Okay? All right, let's take a look at one more bearing problem. So it says the bearing from Pine Knob Fire Tower. So here it's saying that this is, again, this is Pine Knob. I'm going to draw it in my north-south line here. Okay. The bearing from Pine Knob Fire Tower to the Colt Station Fire Tower is 65 degrees to the east. So again, there's my bearing from Pine Knob, 65 degrees to the east, to somewhere over here on this bearing is Colt Station. Okay. Next. The two towers are 30 kilometers apart. So this tower to this tower, 30 kilometers apart. Now, they put the 30 here. Normally it would be a little bit more specific because we don't know. Yeah, I guess, yeah, there's the tower. Never mind. A fire spotted by rangers in each of the towers has a bearing of north 80 degrees to the east from Pine Knob. So here's Pine Knob. From the north, we're going to go 80 degrees to the east. Well, this is 65, so that's not right. To the fire, from the north, and again, it doesn't matter where you start this. So from the north, we're going to rotate 80 degrees. There's 65, so this should actually go to here. Somewhere on that bearing is the fire. Okay. And then south, 70 degrees to the east from Colt Station. So again, putting in our imaginary north-south line. From the south, we're going to rotate towards the east. So from here to here is our 70 degrees. Okay. Find the distance of the fire from each tower. From each tower. So again, here's the fire right here. We can call this side, I don't know, let's just call that whole side A. And from this tower to the fire, from here to here, let's call that side B. So that's what we need to find. Okay, so if A is our unknown, I'm going to start with our A. Okay, A is to the sine of the angle directly across. So if this is our A, this whole side, then we have to be able to find this angle here. So can we find that angle? We know part of it is 70, but what is this part right here? Okay, look for your parallel lines. You see this north-south line. And you see this transversal. So we have two north-south lines here. Let's look for our alternate interior angles. We have parallel line to transversal, transversal to parallel line. So if this is 65, this little piece here is 65. So the angle across from side A is 65 plus 70, which is a total of 135 degrees. Okay, and then we know 30, so somehow we have to be able to calculate that. So how are we going to do that? Well, again, we know that this whole thing is 135. It would be nice if we knew this piece. You know how big this is right here? Well, from here to here is 80, from here to here is 65, then this little piece right here is 15 degrees. So this angle over here is 180 minus our 135 minus our 15 degrees. That gives you 30 degrees. So 30 kilometers is across from 30 degrees. So 30 kilometers is to the sine of 30 degrees. And just like always, to solve for A, I made it real simple by putting your unknown up here. All you have to do is multiply both sides by the sine of 135. Type it into your calculator. And side A, 30 divided by the sine of 30 times the sine of 135 is 42.4 kilometers. Okay. Now we need to find side B. Side B, So that's our unknown. We should probably be able to find the angle across in the triangle, which we already calculated that, so that's nice. And again, using the same given information, 30 kilometers is across from 30 degrees. So if you multiply again, both sides by the sine of 15 degrees in this case, and use your calculator, you will get side B is 15.5 kilometers. So A is from Pine Knob to the fire, and B is Holt Station to the fire. And that is how you do bearings and apply them with the law of sines.